Good afternoon, good day. So aside from this pre-recorded lecture, I also included in the lecture material the YouTube videos, no, to better understand this topic. So even wala ni siya, and even kanang kamuray garid ani nga material, I believe, no, nga makasabot ra mo sa topic and all the computations in this topic. So we'll now move on to this topic, which is the soil compaction and field density. So topic outline are definition and compaction, fundamentals, laboratory test, field density test, compaction equipment, compaction specification, and field control measurements. Intended learning outcomes, you have to understood, at the end of the lecture, or at the end of the if this topic is finished, student understood and explained the principles of soil compaction, generated the soil compaction curve, and calculated the maximum dry density and optimum moisture content, differentiated the properties of the soil on the wet and dry side of the compaction curve, discussed the different field density tests, calculated the relative degree of compaction, identified the different compaction equipment, and discussed the compaction specification and field control measurements. So as you can see, this is the figure or photo, no, of the different this one is a compaction. I think this is like a hammer, no, and a crane. And this one is a potholes in the road or in the pavement. So this one is for, I think this is for repair, no? For compaction. So to be able to mitigate this problem or avoid this problem, then compaction is needed. What is compaction? So compaction is a simple ground improvement technique where the soil is densified through external compactive effort, meaning densified is himuon siya as bugat. So from here, this representation, you have the soil particles, then there is a gap, now which is kanang they are farther from each other, so there are gaps, no, in between. So this makes the soil loose, no, because there are voids, no, in between the soil particles. Adding with water, then plus the compactive effort or compaction, or through, if you happen to visit in a construction site, then kanang sa pavement or sa dalan, ginabalik-balikan na siya og ruler, no, or pison, no, then that is compaction. Then that will become to like this, no. So natapok siya, no, ang soil particles, then gagmay na lang siya og voids, no, or gaps, no, in between. So diha na siya ma-densified because nagtapok naman siya, and the air voids is na-reduce, no. So that is compaction. Compaction is a process of bringing more for compaction. The process of bringing the soil particles closer to a dense state by mechanical means. So we have later on this discussion, we have different mechanical means, no, of doing compaction equipment and like vehicle, no, or like equipment, no. The voids are reduced by expulsion of air and the soil particles are packed together, thereby increasing its unit weight. So that is why densified or mabugat siya. There is no substantial change in the volume of water in soil during compaction. And compaction is done to improve the engineering properties of the soil, such as increase of shear, increase the bearing strength, reduce the compressibility of soil, change the soil properties like shrinkage, frost susceptibility, and permeability of soil. That is why compaction is one of the most important action or kanang procedure that should be followed in making a concrete pavement or PCCP, no? Um, pavement, PCCP, Portland Cement Pavement, Portland Cement Concrete Pavement, no? PCCP. So, naay compaction. So, before doing FDT or field density test, you have to do compaction because there are criteria that the result should reach the criteria specified in the or provision specified in the DPWH standard. No, the compaction and objectives. Compaction: many types of earth construction such as dams, retaining walls, highways, and airport require man-placed soil or fill. To compact a soil, that is, to place it in a dense state. The dense state is achieved and through the reduction of the air voids in the soil with little or no reduction in the water content. This process must not be confused with consolidation because consolidation in which water is squeezed out under the action of continuous static load. So, ang compaction, there is, the water content is not reduced or with little or no reduction water content. While ang consolidation, there is a reduction of water or water is squeezed out, no? That is the difference of compaction and consolidation. The objectives of this compaction is to decrease future settlements, no? Increase shear strength and decrease permeability. Permeability, it is the ability of the material or the soil to permits water to flow, no, in the soil. Another objectives of compaction is increase bearing capacity for foundation support, reduce compressibility and smaller settlement of buildings, and lesser deformation of earth structures, improve stability and lower damage due to frost action. So if we are in the in a country, no, if we are country nga na ay winter season, so compaction, improve stability and lower damage due to frost. So and then heavy highway versus building foundation compaction operation. So there should be a compaction operations even in highway and a building foundation. Then to reduce degree of shrinkage and formation of cracks on drying. We have these different general compaction methods or equipment, no, in the laboratory and in the field. For the laboratory, we have vibrating hammer or the BS. It is used for the fine-grained, for the coarse-grained soils, we have vibrating hammer. And for the fine-grained soils, we have falling weight and hammers, kneading compactors, static loading, and press. For the field, we have hand-operated vibration plates, motorized vibratory rollers, rubber-tired equipment, free-falling weight, dynamic compaction, low-frequency vibration. Then for fine-grained soils, we have hand-operated dampers, ship's foot rollers, rubber-tired rulers. So the method or the process for coarse-grained soil is doing vibration, and for the fine-grained soils, kneading. No, we have for the laboratory test, no, theory of compaction. The origin, this is the history of compaction. Fundamentals of compaction of fine-grained soils are relatively new. R. Proctor in the early 1930s was building dams for the old Bureau of Waterworks and Supply in Los Angeles. So we're not after the origin. The purpose of this laboratory compaction is to determine the proper amount of mixing water to use when compacting the soil in the field and resulting degree of denseness which can be expected from compaction at this optimum water. So the impact of compaction, Proctor test is an impact compaction. The hammer is dropped several times on a soil sample in a mold the mass of hammer, height of drop, number of drops, number of layers of soil, and volume of mold are specified. If only we are in this face-to-face, no, you can experience this Proctor compaction test, no, in our laboratory here in engineering. So mag-perform ang tataan ni, but I'm not sure. So I believe na humana mo sa inyong laboratory, GE43 laboratory, no, because you only enroll, or I believe nga ang akong gihandle is lecture lang. So humana mo sa inyong, or I presume nga humana mo sa inyong laboratory, or yes. Anyway, we have various types of compaction test. Okay, number one is the BS light. Actually, this first column is for different type of equipment, no, and we have the mold and rammer. So this is for the laboratory, no. So for the number one, this is in the laboratory still. Yes. And the rammer mass. This is rammer mass. This is hammer mass, no. Katong ibundak, no, sa mold. Muna siya ang iyahang mass. And the drop, no, from the mold to the hammer. Muna siya ang each drop and number of layers. So meaning after each layer, then we have the blows per layer, no. For this, for number 2, this standard is for the standard Proctor test, this method, and for number 3, this is for modified Proctor test. The usual test, no, nga for compaction is the standard Proctor test. So this is the equipment for the standard Proctor test. So we have this is the mold, and then there is extension, no, and there is this hammer with weight of 5.5 pounds or 2.5 kilograms, and drop is 12 inches or 304.8 millimeters, no. So ingano ni siya. This one is the actual, no, representation of the Proctor test. So pila ka blows for Proctor test. This is, I think, previous slide, 25 blows per layer. It depends. Now, if the mold is 4 inches, then 25 blows. If the mold is 6 inches, 56 blows. So the comparison between the standard and modified Proctor compaction test. This is the summary. Now, this is the summary of standard Proctor compaction test. According to ASTM D698 or AASH, so these are the standards or specifications for doing this standard Proctor compaction test, no. So we have the mold, the volume, height, and diameter of the mold, the weight of the hammer, the height of the drop of hammer, number of soil layers, number of blows per layer, and test on soil, fraction passing sieve. So meaning the test of soil is the kind of soil nga ginagamit for standard Proctor compaction test, you know. Test on soil passing, no, passing the sieve. So for example, method A, dapat mo pass siya og number 4, no. then na-retain sa number 4, dili na to siya mao ang soil. So, ingon ana siya. This is for the summary of modified Proctor compaction test. You can actually notice the difference between the volume, the height, diameter, the weight of the hammer. For the standard, the weight of the hammer is 5.5 pounds. No, and the height of the hammer or height of drop of hammer in the standard Proctor test is 12 inches, while in this modified Proctor compaction test is 18 inches. Now, number of soil layers 5, while in the standard Proctor compaction test 3 only, no? And yes, number of blows. For the comparison summary, we have the standard Proctor test and modified Proctor test. Yeah. Observe, or you can notice that the modified Proctor test is of higher compacting energy because of course of the ang height drop is 18 inches, mas tako siya, and also the weight of the hammer, which is 10 pounds, no? Almost twice of the standard Proctor test. So that is why higher compaction or compacting energy, diba? Potential energy is equal to the magkataas imong height, higher ang energy. So this follows nga dako og compacting energy ang modified Proctor test. Comparison, why in the early days of compaction, because construction equipment was small and gave relatively low compaction densities, a laboratory method that used a small amount of compacting energy was required. As construction equipment and procedures were developed which gave higher densities, it became necessary to increase the amount of compacting energy in the laboratory test. Okay, that is why. The modified test was developed during World War II by the U.S. Army Corps of Engineering to better represent the compaction required for airfield to support heavy aircraft. The point is that increasing the compactive effort tends to increase the maximum dry density as expected, but also decreases the optimum water content. So, as the technology developed, so before, no, katupang early days of compaction, kanang gagmay pa ang equipment. So, ang laboratory, ang standard nga nahimo is kanang for gahatag siya for lower compactive effort. So, then nagka-high tech, no, then especially for aircraft nga bugat kaayo, so kinahanglan og compactive effort nga, so higher densities na, no? So kailangan og kanang compactive effort nga dagko. So that is why na-develop ang modified compaction test, which is of higher compactive effort than the standard Proctor test. So the variables of compaction, Proctor established that compaction is a function of 4 variables, no? We have the compactive effort E. For standard Proctor test, for example, we are given dry density. We are required to determine the dry density or dry unit weight, the water content, compactive effort, and soil type, gradation, presence of clay minerals, etc. So for the standard Proctor test, the formula is to determine the compactive effort, the weight of the hammer times the height of drop of hammer times number of blows per layer times number of layers divided by the volume of the mold. So this is the compactive effort calculation. This is just an example. So the example of standard Proctor test. So for the procedures and results, several samples of same soil but at different water contents are compacted according to the compaction test specification. So this is the first 4 blows. So kung katong standard Proctor test, so the the blows, number of blows per layer, example kung imong mold is 4 inches, only 25. Now, this is the representation for the first 4 blows. Then, every successive blows, may ani na siya, no? Mo compact yun ang soil particle. So, mo nang ma-densify, and magamay ang air voids or mawala, no? So the total or wet density and the actual water content of each compacted sample are measured. So this is the moist density. This is the mass of the soil divided by the total volume. So dry density is actually equal to the moist divided by 1 plus the moisture content or the water content. So the dry density can be derived from the known moist density and the moisture content. Then plot the dry densities, rho sub d versus the water content W for each compacted sample. The curve is called as the compaction curve. Alright, example, this one, no? We have the density of the sample. To determine density of the sample, given the mass of soil plus molds. So this is the mass of moist soil now plus mold that is 5,321 grams, and the mass of mold, this one, no? And the water content sample, the mass of sample plus container. So lahi siya, no? Lahi siya nga container. Example lang is plastic container, gibutang ang moist soil. The weight is 252.6 grams and the mass of dry sample plus container. So pag oven dry na nimo siya, pag weigh na pud nimo, nahimo na lang siya og 238.04 grams. And also prior to that, you weigh the mass of you weigh the container and you obtain 104.73 grams as the mass of your container, no? Then for the calculations now of the water content sample, so these are the data kanilang imong nakuha nga so kanilang imong nakuha nga data. So for the computation of the or calculation of the water content, the mass of water is equal to mass of soil, density of sample. Mass of moist soil plus container is equal to 252.60 minus 238.04. This is para to obtain the mass of the container, para makuha ni siya, the mass of sample plus container, no? Because this is moist soil ni siya, or the soil in the field or in the in situ soil, no? Then mass of after oven drying, no? Then you only obtain the mass of dry sample as 238.04. So that is why to obtain the mass of water, you have to subtract this one, 252.60 minus. And for the mass of dry soil, this is given the mass of soil plus mold. This is moist, no? This is moist, and mass of the mass of dry soil, this is actually equal to mass of dry soil man, di ba? So this is equal to 238.04 minus 104.73 grams. Because mass of dry soil man, we have here the given mass of dry sample plus container. So minus the mass of the container, so we obtain the mass of dry soil. And this water content is 14.56. This is the mass of water divided by the mass of dry soil, di ba? Water content is actually equal to the weight or mass of water divided by the mass of the solid sample or solid, say, dry soil. So from the density sample, the mass of soil in the mold is for the moist soil, that is 5, this is 5321 minus 3449, or in pounds, that is 4.127 pounds. So actually kulang ni siya, no? There should be given volume. To obtain the density, this is the moist density of the soil, no? There should be given volume kani. So actually wala ni siya given in the earlier given of values, no? Wala ni siya. This should be a given also, so that we obtain the density of the moist soil as this one. And for the dry density of should be, to obtain the dry density is equal to the density of the moist divided by 1 plus the unit weight. So we have dry density of the moist as this one, or in kilogram per meter cube, that is 1983, this one, divided by 1.109. So asa manigikan, this is 1 plus the unit weight, which is equal to 10.9%, or 0.109. And this one is this one, no? Because the dry density is this formula. So we obtain the dry density as this answer. So we have here the graph of this is the moisture content versus the moist unit weight, no? Then at compaction effort, at compaction actually, so ga-increase kag moisture content, then there comes a time nga mo reach ka sa imuhang maximum dry density. This is the maximum dry density, this point here. So this is the representation of the water nga ga-increase kag water. So ga-increase kag water, then this is actually your optimum moisture content in which maximum ang imong dry density. But even increasing water, there comes a time also nga mo decrease na pud imong dry density, no? So this is the result, no? At different moisture content. We have these terms, the peak point, line of optimum, and zero air void. This is the water content x-axis versus the dry density. Then we have these two methods, the standard Proctor and the modified Proctor compaction. So as you can see, increasing the compactive effort, that is modified Proctor, will also increase the dry density, but gamay siya og optimum water content. In standard Proctor, no, increasing water content, so this is actually the gitawag nga maximum dry density. This is the maximum dry density. Then if you trace that one, at this point here is your optimum moisture content, no? Ngano importante ni siya? Because this is your basis of your kuan kanang actually na ay criteria, no? Especially kanang kung mag-construct og dalan, then we have to determine the field density test, FDT. So sa FDT, ma-determine mo ang maximum dry density sa soil. Then because naa siya criteria, no? Dapat maximum dry density is, or the relative density should be 95% or better 100%. So inga na siya. Na sumuo nang importante nga ma-obtain na to ang maximum dry density. This is for standard Proctor, and for modified Proctor, this one. And this is the optimum moisture content for modified Proctor. Then we have line of Optimus, this one, no? Line of Optimus, meaning this is the line nga optimum ang moisture content, no? That is the optimum moisture content. Then increasing that one, your dry density, dili na siya maximum. So this is your moisture content nga maximum ang dry density. And we have also this zero air void. So from the term itself, zero air void, wala gyoy void sa air, no? Wala na gyoy space sa air, no? Sa soil particle ninyo. So this is the line of the zero air void. This is the degree of saturation. So at 100% degree of saturation, no, you will achieve the zero air void. Let's move on. This is the explanation. So the peak point of the compaction curve, the point with the maximum dry density. Corresponding to the maximum dry density is a water content known as the optimum water content, also known as the optimum moisture content, or OMC. Note that the maximum dry density is only a maximum for a specific compactive effort and method of compaction. So lahi-lahi sila, no? Ang standard Proctor test and the modified Proctor test. So this does not necessarily reflect the maximum dry density that can be obtained in the field. So actually those modified compaction in the Proctor is for laboratory only. So it does not reflect the maximum dry density that can be obtained in the field. But at least we have this initial or data, no? And then we can actually incorporate in the laboratory to the field. So we have also the zero air voids curve. So the curve represents the fully saturated condition, that is S degree of saturation is 100%. It cannot be reached by, compaction. So the line of Optimus, a line drawn through the peak points of the several compaction curves at different compactive efforts for the same soil, will be almost parallel to a 100% curve. It is called the line of Optimus, or the line at which maximum or optimum ang imong moisture content. And for the equation for the curves, with different degree of saturation is this one, no? This. So this is obtained, no? You can derive this equation by yourself through this a formula. So the dry density is equal to the density of the moist soil divided by 1 plus the void ratio. No? But the right yes, obtain this one using this formula, using this hint. So we move on to the next. So the below dry side of optimum, or below optimum moisture content, below, so the dry side, so diri dapit, di ba? So this part here, this is the, so this part here, kaninga part, the particles develop larger and larger water films around them, so which tend to lubricate the particles and make them easier to be moved about and reoriented into denser configuration. So at the optimum moisture content, the density is at maximum. So in here, no, and it does not increase any further. So this is the maximum density, dry density. Then above, or the wet side of the optimum, this part here, no? So this is the dry side of optimum, and this is the wet side of optimum. So water starts to replace soil particles in the mold, and since you increase man the water content, so there comes a tendency that the water will replace soil particles. And since the density of water is less than density of the soil, the dry density starts to decrease. No? Dry density is moist density 1 plus moisture content. So since you increase the moisture content, if you increase this one, so mudako ang denominator. So kung mudako ang denominator, this one will decrease in the wet side of the optimum. This is the graph, no, of the maximum dry density, and this is the optimum water content. The soil grains densely packed at this portion, no, kung maabot siya dire. So increasing moisture content, then compactive blows by compactive effort, so using the standard or modified, so maka-create mo ani nga curve, no. And then at this point, pag abot ninyo ani, the soil grains densely packed, so meaning that is the maximum is condition of the soil nga dense na gid siya, no, meaning compact na gid ang soil. In this portion, no, of the soil, good strength and stiffness, and low permeability. So each data point on the curve represents a single compaction test, and usually 4 or 5 individual compaction tests are required to completely determine the compaction curve. No? Then at least 2 specimens wet and 2 specimens dry of optimum and water contents, varying by about 2%, no. Dili magid siya magkapera, even the same soil and different specimen, there is a variation of result, no. Optimum water content is typically slightly less than the plastic limit according to AS at TM. Typical values of maximum dry density are around 1.6 to 2.0 megagram per cubic meter, with the maximum range from about 1.3 to 2.4 megagram per cubic meter. And typical optimum water contents are between 10% to 20%, with an outside maximum range of about 5% to 40%. For example, we have this